So after discussing resolution, we move to the second key attribute, which is environmental conditions. Again, we have the 4 modalities, and according to R157, system provider or the OEMs, they must declare the supported ODD, and furthermore, the system shall be able to continuously monitor the environment and disable the ALKS feature where driving occurs outside of the defined ODD. So if we think of a camera, camera is by design the most vulnerable sensor when it comes to lighting conditions or to adverse weather conditions. Now, being a passive sensor, it is entirely dependent on external lighting. Cameras are limited in various conditions, including low light, blinding light, sun glare, sharp transitions in lighting conditions, and weather conditions, adverse weather conditions such as rain, fog, and dust. Moving to LiDAR. So LiDAR is definitely more immune to lighting conditions, to various driving scenarios, and to bad weather. However, it is still has some vulnerabilities, still have some issues. So basically, I can say that LiDAR perception capabilities are often not sufficient to identify weather conditions with a reasonable level of confidence, which is crucial to determine whether it is operating within or outside the ODD. Moving to imaging radar, we all know that imaging radar, like any other type of radar, are immune to lighting conditions, driving scenarios, and bad weather. This is because the wavelength which is being used is in the RF domain, frequencies in the few tens of gigahertz. They can be transmitted through the atmosphere without much of interference. This is why, in practice, these imaging radars can perform normally under adverse weather conditions. Finally, we talk about our CDAR platform, and the CDAR platform, if we compare it to a LiDAR, then the CDAR offers significantly better performance in adverse weather conditions, also immunity to different lighting conditions and driving scenarios. Same if we compare it to a camera. Basically, I can say that it is more resilient to these conditions compared to the competitors, and it has the capability to detect and declare the object very effectively as compared to LiDAR and camera. Can actually summarize what I've just said by this table. So we look at the 4 modalities on the left, and we look at 5 different criteria on the verticals, on the columns. So we can think of scenario of daytime, nighttime, HDR, light weather condition, and severe weather conditions. And as you can see, camera has lots of issues in these scenarios, especially at nighttime, at severe weather conditions, and even sometimes at light weather conditions that could be an issue. LiDAR perform better. Daytime, nighttime, it can perform fairly well, provides sort of mid-level, let's call it HDR, can really perform reasonably at light weather conditions, but it definitely has issues when we are talking about severe weather conditions. As for imaging radar, I've already mentioned it performs very well under severe environmental conditions, but so do our CDAR platform, which perform very well at day, at night, under HDR, at light weather conditions, and even it performs fairly well at severe weather conditions.